Okay. Oops. So thanks. This is a virtual meeting for the TLS working group focusing on ECH. As I just mentioned, this session is being recorded. We're experimenting. If you want to leave your video on, we can try that out and see how it works. But make sure you're muting your microphone unless you're speaking, just to minimize the extraneous noise. We'll try to use the queuing mechanism, although with a smaller group of people here, we may not have to be quite as formal, but I'll try to monitor the queue, and maybe Chris can as well. There are blue sheets. The CodeEMD link is in the chat, which you may have access to. Sometimes that doesn't. If not, it's on the slides, or I think in the meeting announcement as well, or should have sent it in the meeting announcement. And if somebody's on Jabber and can relay any questions from Jabber, that would be great.
Yeah, Joe, unfortunately, it's on, are the slides sent out?
Yeah. The slides are in the meeting. Well, one, they've just been posted to the blue sheets, to the chat.
Yes, good. Because the problem is that you can't click on the slides that are being displayed, and they don't have the URL. They just have the subject. I got it. Thanks. Yeah, and the slides should be in the meeting materials for this, but they may not be obvious because how to get to that. I apologize for not including that information in the announcement. So hopefully people can do that. Here's the note well. For folks that are, you've all seen this before, I'm sure. So just make sure you adhere to the best practices. And we're here to talk about ECH. So what I'm going to do is bring up the GitHub pages and then go on mute and listen to Chris tell me what issues we should be looking at.
Cool. Can you start with 274? All right. So the summary, if you've not gone through this issue, is basically as follows. Right now in the current design, clients are required to use trial decryption to figure out whether or not the inner or outer client hello was accepted, which is a problem for a number of reasons. Perhaps paramount is that it complicates the quick TLS interface in a needless way. So ideally, clients have a way, or the TLS stack has a way to determine which of the client hellos was chosen without consulting quick during any part of the protocol. So there are a number of options here. Option 0, 1, 2, 3, 3 prime. I forget how many options we have now, but we seem to be converging at least on one of them. So if you could, I think if you scroll all the way to the bottom, Joe, it might link. I think Chris summarized the current status. Okay, yes. So there are the three proposals, each with a backing PR. The one that seems to be gaining the most momentum is 287, number 3 here, which adds an explicit signal of confirmation by reusing some bytes in the circle hello random. This seems to be okay from a cryptographic perspective after consulting with people who are involved in the proofs. I guess, Chris, do you want to say anything more about the particular design or the change?
Oh, I don't think so. I mean, from a proof perspective, or something else.
If anything came to mind, I guess.
Yeah. So the idea is basically to provide an explicit signal of acceptance, so that you don't have to do trial decryption. So what happens is the client sends an ECH extension in its client hello inner, which has this 8-byte random value that it expects to see in the server's server hello random. So if it sees that sequence of bytes, then it presumes acceptance. Otherwise, it presumes rejection, or the server doesn't support it. So the idea of this is basically to stick out as little as possible while resolving this trial decryption problem. From an analytical perspective, it doesn't seem to do that much damage because we're just using 8 bytes. An active attacker could, of course, control these 8 bytes and increase the probability of a server random colliding with a previous server random. But there are still 24 bytes of entropy, so this risk seems pretty minimal.
Yeah, and the probability of false positives, that is the 8 bytes, for example, or the client accidentally interpreting that as rejection rather than acceptance or whatever, is like small enough such that like TCP failures happen more often. So I don't think we're really concerned about that. So I guess, yeah, Ecker, go ahead.
Yeah, I mean, I think this is probably, we spent a lot of time on this. Obviously, I think this is probably the best approach. I have some complaints about the way it's spelled, which I can put in comments. Specifically, I don't think having 2 variants of the client hello extension is a good idea. We should have 2 different code points, but I think this is a fine general approach. And I think probably the next thing is if people agree on the general approach, we should just iterate the PR and get it right.
Does anyone object to the proposal? I guess let me ask that question. Okay, cool. That's the case. Yeah, Chris, let's just work through the issues. Any comments that happen to come up on the pull request? Yeah, Jonathan, do you want to come to the mic and ask your question?
Sure. Can you hear me?
Yes.
Yes. Okay. So I was thinking about this a little while ago, and the server could, in an unencrypted extension, send back a blob, like a number, and the indication of acceptance would be it would compute the whatever key for the inner client hello, hash it with some label, and that would be its response. And otherwise, if it was rejecting or if it couldn't decrypt, it would just put random data in this unencrypted extension. And that would mean you end up with the external observer can't determine whether or not you have the server actually accepted or rejected. It can tell if the server doesn't support, but it can tell that anyway. It can tell if the server accepted or rejected, and otherwise, but the external observer can't tell. Sorry, the external observer can't tell whether accept or reject, but the clients can.
The problem with that is that people who don't do ECH at all will not put that extension in. And so the presence or absence of that extension is the problem.
Well, if I understand this correctly, this proposal, we already have that problem.
No, this proposal does not have that problem because you cannot distinguish from looking at the protocol transfer whether ECH was in use or even supported. The only way you can find if ECH is supported is by probing, which is somewhat more inconvenient.
Well, actually, yeah, we could do the same thing. We could smuggle it in the server hello random as well, actually, because that actually follows the same protocol.
That's what this is.
Oh, okay. Sorry, I didn't realize that this was blinded. I thought this was an explicit signal.
Nope. This is taking basically a secret value that the client sends in the inner client hello and putting it in the server hello random. And from the minimal perspective, it's not actively probing to figure out whether ECH is supported. It just looks like any other random 8 bytes.
So I actually, I do think Jonathan's onto something here a little bit, which is that, well, I can't remember what the issue number is when we get to ECH nonce. If we get rid of ECH nonce, then we can just have the low 8 bytes be a digest of client random, but client random has to be random anyway, and then we can dispense with the signal in the client hello.
Yep, good point.
So I mean, it's just a trivial optimization, but it makes life somewhat simpler.
Yep, and less code points.
I mean, you could echo it too, but echoing is visible. Whereas I just fuck, it can't just be a digest because that's a problem. I have to key it somehow, so maybe that won't work.
By the way, I think we know like what are the properties of the thing that need to go in the server hello random, and we can like shed on like the details later on potential optimizations. But yeah, Ben.
Just to Jonathan's point, I wanted to say that one of the design considerations here is split mode, where the server hello is constructed by an entity that does not have the HPKE private key. So that's part of the reason why this proposal is structured this way.
Oh yeah, I was actually thinking that you would use just a key derived from the TLS key, the inner TLS key schedule. So it would just be another, like an exporter key. No, oh, I mean, yeah, an exporter key.
Yeah, I think that'll be quite difficult because given that we're quite possibly offering different client different key shares in the two client hellos, then you're effectively having to trial decrypt at that point. So as you're trying to do Diffie-Hellmans, like I mean, I think this is certainly an idea worth iterating on, but after like 5 minutes of one full start, I'm less confident we can make it work. But if someone, I mean, certainly, I don't love the thing in the client hello, so we can probably make it rid of it. I'm certainly in favor of doing that.
Yeah. Okay. Unless there's any other objections, Chris, let's just work forward, closing out this PR, incorporating all the suggestions from everyone. So again, the PR is linked here, number 287. If you have specific comments on how it's spelled, like shedding, whatever, please take a look, add your comments there, your feedback there. We'd like to close on this one soon because it's one of the big things that's blocking implementations going forward. All right. Yeah, and we'll close out the other two. Thank you. Joe, can we go back? Actually, I think it'd be good to talk about the nonce thing yet next. So number 253, I think it is. Yeah. Okay. So thanks, Ben, for filing this. The ECH nonce sort of carried over from previous incarnations of the design back when it was just ES&I. And it had a valid use at the time in preventing this client reaction attack. But given how the design has morphed lately, and the fact that the inner client hello presumably has a different secret random value than that which is in the outer client hello, it may be redundant, and we might consider removing it rather than clarifying its existence. There are a couple caveats here. In particular, it does need to remain secret in order for this to be like effective. That's a key property of the ECH nonce right now. Like if it's revealed, then this reaction attack is potentially possible. And there may be servers that somehow leak, bits of the client hello, the client hello random, or like maybe even other extension values like the ECH nonce. So if we're reasonably sure that the random values from the inner outer client hello are different, that is independently generated at random, and that the inner hello client random is never leaked by any entity who has visibility into it, then we may be able to remove it after discussions with Karthik and some others. So Ecker? Oh, sorry, Chris.
Hi, so I just wanted to make people aware of the PR for this. So this PR removes the ECH nonce and it clarifies the the client behavior around generating the inner client hello random.
Does it also say anything about the secrecy of the random value?
Well, so the secrecy is it's encrypted, so that's supposed to provide the secrecy. But yeah, so there I changed I changed the I updated the discussion in security considerations about this client reaction attack to say that the secrecy of the client hello, the inner client hello random prevents that attack. I guess we should all, we should all agree, we should all try to agree that that's actually the case. Worth talking about.
Yeah. So, yeah, I mean, I think Chris and I were talking this. Chris Wood and I were talking this morning. The reason we kept this was because there was some fear that servers might leak the client hello random, for instance, in a ticket. So, and bear in mind, like the ticket does not currently have a secrecy requirement. So I mean, like for instance, you might. I mean, I don't know why you do this, but you might like basically embed the entire client hello in the ticket. And obviously, if that were the case, then you that won't work. Obviously, if that were the case, then this would not work. But with that said, if you leak the client hello in the ticket and you leak the the only way this like really is a problem is if for some unknown all of it, is a bit to do it.
So, Ecker, you were breaking up quite a lot. But what I think I heard you say is that if you expect a server to leak the client hello random, it's plausible that that same server would also leak potentially other information about the extensions, including the ECH nodes.
Yes, that's what I was saying. Is it better now?
Okay. Yeah, it's better now.
Okay. Yeah, I mean, I think that I'm not on the server side reviewed all the DHTs, and so I'm more or less excited.
Yeah.
I don't know about others, but I couldn't follow what he just said.
Yeah, everyone should just turn off video.
Sure. No, I don't know. Is that any better?
Seems to be.
Okay.
Yeah.
So what I was saying was that given that we're hypothesizing servers which have unknown behavior and leak parts of things, the only way to fix that is by pulling stuff out of the key schedule and shoving it back in. And we can't do that without making major modifications, like the communication between the facing and the backend server.
Right. I agree with that.
Thank you. That came through clearly.
Okay. So I guess the question on the table is, do we believe that with this sort of change in which we make it clear that the two client hello randoms need to be different and that the inner one needs to remain secret, whether or not that's sufficient, or we need something a bit stronger?
I think the question is, how long does it need to be secret? It needs to be secret. It needs to be unpredictable to the adversary prior to the client consuming the server's the server's first flight.
I mean, yeah. I don't know if that's a useful distinction, but perhaps it is. But yes, it cannot be revealed up before that point, certainly.
So I guess, yeah.
As a resumption, does that break things?
Why would it be revealed during resumption?
No, if you leak the client hello, and then subsequently the connection is torn down and then there's a resumption, does that change the security properties? I'm just trying to think of cases where you might end up consuming the server first flight later than you think you will.
Not sure offhand. Ben?
Ben Schwartz, I'm not sure I follow all this, but it seems like anything that leaks the client hello random in session tickets or a resumption also creates a pretty severe linkability problem that we would probably want to prohibit anyway.
So if we do end up with some hack where server hello random is derived from client hello random, then it of course has to be client hello random has to be secret in perpetuity.
Right. So actually, I meant independent of anything to do with encrypted client hello. If session resumption is revealing the client hello random in clear text, then an observer now can link the resumptions back to the original session.
Agreed. I'm sorry, I wasn't.
Which seems like a problem bad enough that we might want to prohibit that if we're worried that it might be a behavior in the wild.
I agree. I was just trying to make a separate point. My mistake.
Yeah, okay. So does anyone have any objections to this, I guess, proposal going forward with the added clarity?
What proposal?
2 independently generated random values, language around the inner one saying that it must be kept secret.
As long as that doesn't prohibit us from saying, sorry, Jonathan, as long as that doesn't prohibit us from coming up with a better design.
There is no better design, Jonathan. I mean, I'm kidding.
You know, 2 things derived from the same secret are guaranteed to be independent. So, sorry, with different labels.
Are you asking, like, are you suggesting a way to generate the 2 random values?
Yeah.
Oh,
yeah.
I mean, it seems like an implementation detail that, but.
But you can do it without having to have 3. Sorry, if you derive it from 3 different labels, then you can have one that remains secret because it's never transmitted, and one that's the outer and one that's the inner, for example.
Yeah, I mean, this seems like a detail of how one writes when it's PRNG.
Yeah, I would agree.
But
I think in most cases, like most TLS stacks would just like call random bytes and take whatever output and just shove it in the client hello random. I mean, that's the ones I'm familiar with. That's what they do. And this would be no different, I would imagine. So I think, Jonathan, an implementation could choose to do what you're suggesting. I don't think it needs to be spelled out in the specification. I mean, yeah, if we don't trust the client's RNG, then I think there are worse issues. Christian, do you want to comment at the mic regarding 287? I know we've kind of moved past that, but I'm not sure.
Yeah, I was looking at that. I was going to add a me too, yes, I like it to 287. And then I think I have an attack against that. And the attack is, suppose a man in the middle observes the client hello, forwards it to the server, receives the server's hello, blocks it, and sends and creates its own response as if he was a server responding to the outer initial client hello. but does copy the first 8 bytes of the server hello random into its own server hello random, then I think you have an oracle. Is that the client will see if the client is doing ECH, it will react to the 8 bytes and try to use the ECH secret, and the connection will fail. And thus the server can see that because the connection doesn't progress, the client and the server were doing ECH.
Yeah, I don't think this design is specifically intended to prevent that sort of active attack. I mean, there's certainly other ways to figure out whether or not a particular connection it makes use of ECH, depending on like what sort of capabilities you assume the on-path attacker to have and how much active probing or whatnot it's willing to do. This is more to prevent sort of obvious like plain text filters that might block ECH on the presence of a clear text signal in the server hello.
So my real concern there is that, I mean, the weakness in the design is that there is a copy of something in clear text in the first 8 bytes. So that means that it's observable by outsider, and it can be used in a variety of replay attacks. And I just draw one. That would not happen if the 8 bytes were somehow constructed so that they could not be guessed by a third party. For example, if Chengding, but I mean, maybe I'm just over concerned.
I think it's good to think these things through clearly. Perhaps if you could articulate the attack in a bit more detail on either the issue or the pull request, we can further examine it there.
Yeah.
Okay, thank you. And thank you for raising it. Watson?
Yeah, I'm just a little confused. Was that because of the 8 bytes, is that about 274 or the one we're discussing now, 253, where there's a concern about the attack?
That was the previous one, I believe, 287. But Christian can correct me if I'm wrong.
No, that was about 287. Correct.
Okay, yeah. Okay, so let's follow up on the PR there and think through that case just to make sure that there's no inherent problems. But yeah, thanks again for flagging it. So back to this one that's open right now. It doesn't look like there's any particular strong objections to it. So Chris, your PR is linked from this issue, right?
I'll put an actual comment in it.
Okay. Yeah. Let's similar to the other one. Let's just review it and then move it forward, and then close it out. And thanks again to Ben for filing the issue. All right. Number 264, please. Right. Okay. So one of the details we lay out in the spec is that endpoints must pad parts of their handshake flight in order to hide, metadata that would leak otherwise, like size certificate that might depend on the SNI or other things. We currently rely on record layer padding to do so, but as David lays out in the issue, this could be problematic for quick implementations. There's also a potential to do it with extensions on certain messages in the handshake, like you could make an exception for padding being added to the certificate message or to EE or whatever. There are some comments in here that suggest that doing it, going down the extension route is perhaps not the best path, particularly if you consider what happens with certificate compression. So I think the proposal here is to add a new handshake message that is specifically designed to carry padding bytes. and the part of the record layer that looks at the handshake message and dispatches it to the state machine, similar to CCS, would just consume this padding message and drop it on the floor. Unfortunately, David is not here to speak to it, I don't think. So I wanted to, I guess, open the floor to see if what people thought about this particular issue. Specifically, if there are people here who are involved in the quick side of things, like Christian, that would be good to know, or it would be good to hear your feedback on this particular problem. Becker?
Yeah, I'm really not enthusiastic about adding a new a new padding a new padding message, handshake message. Yeah, that seems like gross. I guess I don't quite understand why we can't add all the padding in EE if we have to add padding. I mean, that requires recomputation, but it's not like it's not that the record boundaries are not sorry, that the handshake message boundaries are not visible at the record layer on the wire.
I guess, I mean, from the server's flight, I guess I don't see an issue with it either. I don't know if like the client doesn't have an EE.
Well, that's true. Well, then I'd rather add EE there, because like, if the problem is that we like need to put things in other places, like the idea that we're going to add a new handshake message and use a state machine explicitly for the purpose of like saying nothing, like does not work well for me.
Can you elaborate on that? Is it just because it's
it just seems like extremely a point fix for Linux should have a generic solution.
I see. Okay. Nick?
Sorry, I added myself to the queue to comment that from the quick perspective, managing padding at the quick layer will be horribly complicated. So we need some sort of padding in the TLS layer. I don't have strong opinions on where TLS puts that padding in. So what Ecker was suggesting of putting it in E instead of in a new handshake message, I think sounds fine.
Yeah. But we also, Chris, I don't understand why you would need to add client server. For client server padding, are you talking about the client hello or about the client certificate?
The client certificate. Like I don't know.
But that's not covered by SNI anyway, right?
Well, I'm imagining like a potential scenario where the client cert varies based on what the SNI instance is. But
sure,
like, I don't know if that's actually the problem in practice.
Well, but I mean, I guess, right. I mean, that's certainly true. But bear in mind that like lots of things are going to vary based on what server it is, right? Once you're talking about like my message high traffic analysis, like what is the URI going to vary? So I don't think that's helpful. But in any case, so I think that's not like this seems like a separate problem.
Yeah, I guess we could go to differing extremes here with how much.
I guess let me point out that like it seems the client certificate leakage has like much more serious problems than with SNI, because you have multiple clients connecting to the same known server, and you're potentially leaking that any of those. So it seems like if that's an issue, like that's a solution which can be detached from this particular problem.
Yeah, I would agree with that. And whatever mechanism you happen to use to address the padding for ECH could probably be used to solve that particular problem as well. Be it like an extension somewhere on the client's flight after EE or after the server's flight, or a handshake message. Like I too don't really have a strong preference, as long as it's not in the record layer, as Nick and David has pointed out.
I agree with that.
Yeah. Does anyone have a strong opinion, Chris?
I just wanted to mention one thing we're not talking about, which is definitely less of a risk than leaking the SNI, is there's a lot of things in the spec about don't stick out, like padding to make sure, like on ECH rejection, you pad it. Like it's optional for non-ECH servers to pad to hide the fact that ECH rejection has happened. I don't know how that concern relates to the questions on the table. I just wanted to bring that up.
Right. I think one more point. David Ben points out that the reason you can't do just an extension of the certificate message is because the certificate compression draft, compresses the entire method.
Exactly.
But like we could just pull that out of the RF editor and fix that. I mean, if we decide that was the wrong answer, like we just fix that. So I guess I'm not sure it is the right answer, but I guess what I'm saying is if people think that's off the table because the document's been approved, that's not off the table.
I forget where that document is currently.
Or 48.
Yeah. Okay.
But I mean, so like, maybe the chair could push the pause button.
Perhaps. Yeah. Yeah. I mean, that seems reasonable.
I think we should press the pause button on that until we make sure we have a resolution to this.
Yeah.
Okay, I will push the pause button for certificate compression.
Thank you, Ben. Okay, so it sounds like in general, folks are not enthusiastic about doing this in the record layer. We need some way to do this within TLS, particular mechanism TBD. But all this is sort of like extra anyways. I mean, different implementations might go to different degrees of how much padding they're willing to do to hide these things. Like padding is not required to make the protocol work. So I don't consider this a real blocker, but it's something we should figure out. Okay, anyone else have any other follow-up comments?
One thing is that if we should double check the draft to see if there's any must pads. I don't know that there are, but that's worth following up on just in case we don't actually if we don't actually basically if implementations do different things, we still want to make sure that they're standard compliant. So it's worth combing through the spec, I think.
Yeah, agreed. Would you mind, Chris, if you're in the issue right now, could you make a note of what we just talked about? Basically, people are in favor of not record layer.
Yep.
Thank you. All right, can we go to 263 next?
Ben Schwartz. I just wanted to, on the topic of unsolicited padding extensions, I just wanted to ask, is there a way to implement the inner client hello padding using the unencrypted client hello padding extension, which would then be encrypted by ECH?
Yeah, I think that's exactly right. I think that if the client pads, so my thesis would be that the client pads with the standard padding extension and the server then we remove the restriction that the server can't add their own padding extension, and they put it in EE, and then it's not unsolicited, and we're good to go. And then there's an edge case where the client doesn't pad, but the server wants to, but that's just dumb because because the client was too lazy to pad, and the server padding is not going to help us. So I think that seems like the easiest solution to this problem.
Yeah, I would like to find a good place to solve the separate problem of perhaps hiding what the client cert is by the size. I would like to at least have an answer to that as well, even if it is orthogonal to this particular issue.
Well, note that, yeah, I think that seems reasonable.
Yeah.
But bear in mind that you could solve actually by having that. You can actually solve by having So this is why the certificate compression thing is relevant, right? Because that you could solve by padding the certificate in certificate message and having the server. And although unsolicited certificate extensions, I think, are forbidden, because that's in response to certificate request, you could have the extension there.
Yeah, I think that's right. Okay. Well, with Ben putting the pause on compression, sorry to Victor and Alessandro if you're here. We can sort that out. Okay. So this next issue. Back in. Oh, right. So for the extension compression mechanism that we have in the spec right now, there is this hash that's included of what should be the effectively reconstructed client hello. And Chris is asking here whether or not that's actually useful. Chris, do you want to elaborate?
Yeah. So from where I stand, it seems to be redundant, at least insofar as if the client hello, if the outer extensions are manipulated, it's going to change the client hello inner. The client and backend server aren't going to agree on that value, so that's basically just inactive attack. That's what it amounts to. But Ecker pointed out this kind of weird corner case where there's you have these sort of it's possible to come up with contrived examples of extensions that that kind of break the privacy of SNI, and this mechanism, basically this binding of the outer extensions to the client hello inner, prevents this attack. So basically what we have is a strictly stronger security property for the client hello inner that's consumed by the backend server than what is usual for like TLS. So I'm not opposed to leaving the mechanism in there. I thought it warranted discussion. Like, are there more natural examples of extensions for which this stronger security property would be useful?
So I don't have a more natural example. I think part of what happened here is that, we found it so hard to reason about everything involving ECH that that I decided that that this was a sketchy enough kind of like situation that that it was better to be err on the safe side. I think is basically what happened here. That a lot of basically we had a lot of problems with the substitution of individual parts of the inner hello and the advantage. And so here's how you get to this point: is you say, look, we've had problems substituting inner parts to client hello, and so now we're gonna take the entire thing and bundle it in ECH, and that provides both confidentiality and integrity for the entire thing. And so that's a good property, and we agree we can analyze that easily. And then you say, okay, but that's too big, so how do you compress it? And so when you compress it, you don't want to remove the property of having integrity for the entire thing, and so that means you need a binding between the inner and outer. So I guess unless we had a very this is a complicated enough system that it seems like leaving the door open for obvious mistakes later is not a good idea.
So I don't this is kind of maybe nitpicky, so I don't really have a strong opinion about this at this point. I think that though basically I don't know that it's providing additional integrity, but it's certainly it's kind of like encryption with associated data. So it's so basically what we need from the encrypted client hello encryption mechanism is IND-CCA security, and this amounts to an attack on the IND-CCA security of the thing when you have associated data. So what we're effectively endowing HPKE with is public key encryption with associated data, and whether that's necessary or not, I think depends on how you're using the outer extensions. I'm happy with the resolution being, let's just do the conservative thing. It doesn't hurt anything. It's not that expensive. So I'm happy to leave the mechanism as it is and close the issue.
That sounds good. Are there any objections? Okay. Chris, can you note that in the issue, please?
Yes, sir.
Thank you. Let's back up. To 262, please. Okay. Chris, I'm just going to turn this over to you to talk about the issue.
Alrighty, hold on a second. 262.
This is making general expression mechanism.
Oh yeah. Okay, so yeah, where we basically so the people who have chimed in on this issue, we all basically agree that we would like for the extension compression mechanism to preserve the order of the extensions, which the current mechanism doesn't. So there's a proposal for doing this, and we haven't gotten much feedback. There's some pushback from Martin Thompson. If he's here, he can comment on it. But basically, there's a proposal and for fixing this, and I'm looking for feedback. I'm waiting for feedback.
So your proposal is to have multiple extensions?
Yeah. So right now the idea is we have this sort of breaks the semantics of extensions as usual. My thinking is that client hello inner isn't a real handshake message.
Sure.
It's something that you need to actually inflate and send to the backend server. So I figured that it would be okay to violate that rule.
Sure, yes. You're triumphantly reinventing my original design. Although my original design, I think, was less, if I understand yours, was less fancy in that each outer extension only corresponded to one extension as opposed to a set.
No, that's what's going on here actually. So yeah, I went with the simplest, least fancy thing.
Oh, so you have triumphantly reinvented my original design.
Yeah.
Okay, so I guess I'm have to say this. So do you have n hashes then?
No. So there's two extension points for this mechanism. Okay. There's outer extension. And for each extension you want to shallow copy into the client hello inner, you replace that extension with that extension point, and then the payload is just the extension type that's pointed to.
Okay, yeah. Okay.
And then there's an outer extension, what I call the outer extension binder, which has the hash of the whole client hello inner.
Right. Okay. Yeah, because that was the objection to my design, which is I had n hashes. Which my thesis was, by the way, that like, why not? Because you're not. So my original design was each hash was the hash of the thing you were plugging in, as opposed to being a total hash. So I think the objection was. So I think the question here is are there? Yeah. So this is fine. I'm not sure. I'll have to check the spelling, but I mean, this seems generally okay.
Okay. Yeah, I'd be curious. I mean, because I know that Martin Thompson has. So he's suggesting something that actually provides better compression. So the current proposal is really simple. It only actually provides a benefit if you compress enough extensions. So there's a threshold that you need to cross for it to be valuable, which is worth discussing. And I think the other issue is whether people are going to be fine with using multiple extension points in the same synthetic message. So I'd like to see what people think about that.
Yeah, I guess right. I'm not like. I think the next stage is for someone to actually go through a client hello, like some candidate client hello, and like see how any of these perform, because for like how many, like what can actually be compressed. I
mean, I would compress key shares, for example. If you're going to have multiple key shares, it's worth it.
Right. It's only barely worth it though. I mean, so I assume you're using .256 effectively.
For the hash, you're using whatever KDF HPKE supports.
Right.
So we're binding it to the HPKE.
So this is only in this scenario where you're offering P256 and
25519,
you save about 50 bytes, right?
Right. But I mean, if you have a post quantum like hybrid key exchange, then it is worth it.
Yeah. No, I mean, I guess right. So I guess like when this was so like I feel like we're doing history today, but the way we got here is like initially we had a version with no compression at all, and then people were like, "What about post quantum and stuff like that?" And I was like, "Fine, I'll have some compression." And so I guess what my put would be, let's go and look at some candidate examples and see what we're trying to do, and then take the simplest thing that gets us meaningful compression with those candidate examples, right? And if the answer is the only thing worth compressing is key share, and it's only worth doing if you have post-quantum, then your design is pretty good, or even my design was pretty good, right?
Right.
So the rationale for having something more complicated is if you have a lot of big things, you have a number of sort of modest-sized things, each of which needs to be compressed, right? And I think that. And so, you know, I just think like before, like rather than sort of designing in a vacuum, we should actually go look and like see, like a typical client, how many things are going to benefit from this treatment.
I think it's a good idea. So I'm working on a prototype in Go, and I'll implement this mechanism and see if it makes sense, and report back.
All right, thanks, Chris. Ben, I think you're next.
Schwartz. I just want to try to understand whether this is motivated by allowing the representation of arbitrary extension orders, or if there's some other reason why you think the current model is insufficient. Because I'm not aware of a reason that we need to be able to represent extensions in an arbitrary order.
That's a good question. The thing I worry about is there's already a rule in 8446 that says when you can send a pre-shared key extension, like in what order in the client hello. I worry about messing things up if the order, like somehow our transformation of client hello inner to compressed client hello inner, if it changes the orders of things, that could change the expectations of the client and mess up logic on the client side. So basically, I'm worried about ossification of around extension order on the client side. So that the issue, I think that people generally seem to agree that that's a safe thing to do. I forget if you chimed in on this issue or not.
I haven't commented on this issue. If the concern is just about potential ossification due to keys regularly appearing in some order, then there are lots of different possible solutions to that, including like deterministically greasing the extension order in some way.
But there's also like 8446 makes it doesn't assign the order of extensions except for one. I forget which one it was, but I'm pretty sure it's pre-shared key.
Yeah,
it has to appear last. So if somehow your implementation of client hello inner compression messed up that order, then you would end up with a non-compliant client. So it's something to be careful of for a particular implementation of the compression mechanism. I think it makes sense to simplify the spec, and that's what I'm aiming to do with this. It's basically to, it preventing the order of extensions from changing ensures that no logic anywhere else in the stack is screwed up, and that's kind of my aim.
Yeah, so I think to put my cards on the table, my suggestion is, so first of all, people are asking about PSK. Even if there is PSK is clearly not compressible because the binders refer to the rest of the handshake.
Right.
So that's that's not going to work anyway. So I'm not worried about that one. So to the extent to which we should do the research, but if the answer is that the only thing that's really compressible right now in a sensible way is key share, then I propose we just go with the simplest thing, which is the thing currently in the spec, and say that, if there are other extensions, they have to be contiguous. And if we have two, then I think maybe it's worth working on them being decontiguous. Yeah, Ben, ALPN is compressible in some sense, but ALPNs are typically very short. And so given that the minimum size of this extension is like, is like 4 octets, you're not getting much value out of it. You're getting like 5 bytes. So I think like let's do that research and then do that simplest thing. And the thing I would note is that this is not like an all-time commitment in the sense that that because there's an effectively a negotiation when ECH is done, if we end up with some other extension, then we can just we can effectively rev the ECH spec or have a way for the server to indicate I speak compression v2 and have some more fancier thing.
That's fine. I think one thing about like just requiring the compressed extensions to be contiguous, you want to put the outer extension in the right order. So if the extensions are A, B, C, and D, and you're going to compress B and C, then in the representation of the client in the client hello inner needs to be A, and then outer extensions for B and C, and then D.
Right, agreed. And so I guess all I'm saying is, if all you're compressing is key share, it doesn't matter, right? And so like when we introduce compressible extension number 2, then implementations can just choose to serialize that next to key share, right? And so this only really occurs if we already have a bunch of implementations which serialize in some random order, or if you have, for some reason, extensions which for some reason don't want to be contiguous, right? Like in the same way as PSK is now. And so I guess what I'm saying is, unless we find ourselves in that situation now, like let's burn the bridge when we come to it.
I think that's fair.
So see if I guess like what I'm saying is, like, someone should go look at some client hellos and like see is there anything else.
Yeah, we'll take an action to do that with our prototype, and we can talk with others who are implementing as well. And then we can report back on the issue to see what's actually useful. All right, we only have a few more minutes left, so let's move on to 297. Chris, again, I'll turn this over to you.
Yeah, thanks. So what's going on here is, right. So if the structure of the encrypted client hello, that is the payload that's sent in the outer client hello, if that changes, then if that's changed in future versions of ECH, then that'll break backwards compatibility because oh, well, hold on a second. So there's a version negotiation for which draft of ECH you want to use, and it's based on the version indicated in the configuration. So the server indicates which versions it supports, and the client chooses a version effectively. If in future versions the structure of the client encrypted CH structure changes, then that will break backwards compatibility. So I was suggesting we should put the version in the client encrypted CH structure. David Benjamin pointed out, why do we need this in the first place? And I wanted to talk about that. I don't really have an informed opinion on whether it's useful to be able to negotiate the version of ECH. So I was wondering if people would chime in on that. I wish David was here because he brought this up. But
so what you need on the server side is to be able to determine which, because the versions and the configs are one-to-one, you need to be able to determine which config was used. And in order to do that, you need to be able to process the first 2 fields, namely the cipher suite field to tell you which hash to use, and then the next field has the hash to the config, and everything else can be freeform, right? What we're committing to, what we're committing to now is is those first 2 fields be unchangeable, right? And I agree. And I think what you're proposing is to be committing to something else, which is the first field be unchangeable, be virgin, right?
Yes.
So I guess I think I'm with David in the sense that, like, if we really decided we were like sad about like that isn't the first 2 field structure, then we could just invent some new set of code points. I think I am balanced prefer to remove version, but I'm not, I mean, if it were there, and like if we were in last call and it were there, I probably wouldn't fight about it.
I think I would agree as well. Like the first two fields being in invariant seems pretty much are pretty sane to me. I don't think it's documented anywhere in particular that like these two, we expect these two to not change, but we could do that. And then if we need to make something new down the line because we want to change the variance, we just use a different code point.
Well, people have discussed various ways of indicating which configuration was used. Basically, like Nick Sullivan once proposed, like let's have like a super truncated hash, which I guess is the same. Like it's still a config hash technically, but I guess I'm concerned that in order to as an anti-ossification measure, these might change in the future. So like I'm not sure that we want to commit to them. I'm happy. I don't see a reason to change them from where I sit. Like it seems like this is like the necessary information for picking the configuration today. We just can't change the way the configuration is picked. So if anyone can envision changing that in the future, I think then we should add the version.
I mean, to your point, the proposal from David that Nick was mentioning does allow you to truncate because it's variable length. But yes, I agree with the general sentiment. Ben?
Ben Schwartz, I don't really understand the ossification concern that you're mentioning here, because the only way that this ever gets used with a future version is with clients and servers that are both aware of this new version. Like the server has to advertise a configuration with the new version, and the client has to adopt that one. So like, who is the ossified party who's not playing ball? The only thing I can think of is maybe if there were a middle box that is trying to parse this extension, even though it can't understand it. Maybe that is something to worry about. But
well, that's the issue I was talking about. It's not the client or server.
Okay, thanks. That makes the concern a lot clearer to me.
Yeah, so I think we're out of time, and so to respect everybody's time, I think we'll call it here and take some of this discussion to the list. I think we'll also try to schedule another one of these in roughly a week, maybe a little bit longer, to give Rupert to find a good time, or 2 weeks. Okay, 2 weeks. Yeah, thanks for joining, and remember to sign the attendance sheets.
So.